Encryption is a crucial technique used to secure communication by transforming sensitive information into a coded format that can only be deciphered by authorized parties. Its primary purpose is to protect data from unauthorized access, ensuring confidentiality and integrity. Understanding both symmetric and asymmetric encryption is essential, as each method serves different needs and scenarios in secure communication. This foundational knowledge sets the stage for exploring how Alice and Bob effectively utilize encryption to safeguard their exchanges, illustrating the practical applications of these concepts in real-world situations. Symmetric encryption is a method where the same key is used for both encrypting and decrypting data, making it efficient for secure communication. For instance, Alice and Bob can use this technique to exchange messages, but they face challenges in securely sharing the encryption key. If they send the key or passphrase through unsecured channels, it becomes vulnerable to interception by malicious actors. This highlights the limitations of symmetric encryption, as the security of the entire system relies heavily on the safe transmission of the shared key. Asymmetric encryption addresses the challenges posed by symmetric encryption by utilizing a pair of keys, a public key for encryption and a private key for decryption. This system can be likened to a mailbox. Anyone can drop a letter into the mailbox using the public key, but only the owner with the private key can retrieve it. This key pair mechanism enhances security, as the private key never needs to be shared, significantly reducing the risk of interception. Consequently, asymmetric encryption offers a more secure alternative for protecting sensitive communications. Alice and Bob generate their key pairs using the RSA algorithm, which involves a series of mathematical steps on their computers. First, they select two large prime numbers and compute their product, which forms the basis of their public key. The public key is then paired with a private key derived through a specific mathematical relationship involving modular arithmetic. This relationship ensures that while the public key can be shared openly, knowing it does not compromise the private key, thus maintaining a high level of security in their communications. Alice and Bob begin their secure communication by exchanging their public keys, ensuring that each has the other's key for encryption. When Alice wants to send a document to Bob, she encrypts it using Bob's public key, transforming the message into a secure format that only he can access. This process guarantees that even if the encrypted document is intercepted during transmission, it remains unreadable to anyone else. Only Bob, possessing the corresponding private key, can decrypt the message, ensuring that their communication remains confidential and secure. Protecting private keys in asymmetric encryption is crucial, as their theft poses significant security risks. If an attacker gains access to Bob's private key, they could decrypt any messages intended for him, compromising the confidentiality of Alice's communications. This underscores the importance of safeguarding private keys, as they are the linchpin of secure exchanges. Both Alice and Bob must diligently maintain the confidentiality of their private keys, employing strong security measures to prevent unauthorized access, ensuring that their communication remains secure and protected from potential threats. Asymmetric encryption is widely utilized in everyday technology, enhancing security across various platforms. One prominent application is HTTPS, which secures web browsing by encrypting data exchanged between users and websites, ensuring safe transactions and privacy. Additionally, Pretty Good Privacy, or PGP, is employed for secure email communication, allowing users to encrypt messages and verify identities through public and private keys. Furthermore, Bitcoin leverages asymmetric encryption in its cryptocurrency transactions, ensuring that only the rightful owner can access and transfer their digital assets, thereby maintaining the integrity of the system.